looking at question 1, the first question that I've highlighted is part 2 there. Why isotopes of carbon have the same chemical properties? Well, it's because the chemical properties are dictated by the number of outer electrons, not by the number of neutrons. And so things like the number of bonds that carbon can make, it can make 4 bonds because it's got 4 outer electrons, and we call that the valency. So that's not going to be altered by the number of neutrons, which is the difference between carbon-12 and carbon-13. In the essay question, we were looking at 2 particular command words. So to describe the bonding in graphite and to explain the bonding in graphite. So when I approach these questions, the first thing I look at is what those command words actually mean. So describe means to give an account of something, and explain means to set out what causes that phenomenon you've observed. So it says describe the bonding and structure of graphite. So its bonding is giant covalent bonding in layers, and I also could have got the mark by drawing those individual layers. And you could also have said that each carbon atom, which I've represented as circles, is bonded to 3 others. Those were the points that we needed for the describe. We're then looking at explanation, which is set out the causes for certain phenomenon. In this case, the phenomenon is that it's a good conductor, that it's soft, and it has a high melting point. The reason why it's soft is because the layers that we get there, they can slide over each other due to the weak London forces between the layers. The melting point is high because you're having to break the strong covalent bonds, and it's a good electrical conductor because, remember from our previous part of the question, carbon has 4 outer electrons, and in our structure it's only made 3 bonds, whereas carbon has a valency of 4, and therefore there's 1 free electron left over. So those free electrons live between the layers, and they can therefore conduct the charge. In the third part of the question, we are asked to look at calculating the number of moles of carbon in a pencil. Whenever I approach a moles question, remember I would bug the question. So B for box, U for underline, and G for group. Okay, so I'm boxing the command word, which in this case is calculate. I'm underlining the key terms, which is generally the units that it's wanting me to work out, which is the amount in moles. Okay, because carbon is a solid, I therefore know what moles equation I'm going to use. It's just mass over RAM. Remember, carbon's an element, so I'm using RAM, not MR or RFM. MR would be for a molecular element or for a molecular covalent compound, and RFM would be for an ionic compound. And then I'm grouping the different groups. Well, in this case I've only got one group, the group for carbon, and it tells me I've got 0.321 grams of carbon. So that's the mass that I'm given. I know that my RAM of carbon is 12.0, and I can therefore work out my answer as 0.0268. I've given that answer to 3 significant figures because that's the number of significant figures that are set out in the question there, where there's 0.321 grams of carbon. In the number of particles, I'm just rearranging or using my number of particles equals number of moles times Avogadro's number. I've been given the number of moles in the previous question, or I worked it out. Avogadro's number is 6.023 times 10 to the 23, and that gives me 1.61 times 10 to the 22 atoms.